All right, let's get to work. All right. Okay, so here, so if you remember last time, okay? Oh, that's what I wanted to say. I do have office hours today. I will send out the link once class ends. I have office hours from 2 to 3. So last time, we saw these quadratic functions, right? We have f of x is ax squared plus bx plus c. And you can also see that the domain, that's always going to be all real numbers. But really, if you want to graph it, you need to have the vertex, which is given by this formula. The axis of symmetry, it's good to have as well. And remember, that's the vertical line through the vertex. In other words, it's the vertical line with this equation, as you can see. And remember, with the axis of symmetry, the idea is that if you were to take the graph and fold it about the axis of symmetry, if you were to fold the graph about it, both halves of the graph would line up exactly. They would overlap, in other words. Okay. Now, for the y-intercept, remember, that's always f of 0. Although really, you should be able to see that it's just going to be the constant term. Mostly because when you replace x by 0, the terms involving x are going to vanish. Not only that, for the x-intercepts, you can use the quadratic formula. You could factor, if you wanted to. Factoring is still important. For quadratic functions like this, yeah, we do have the quadratic formula. As you go into higher levels of math, if you do, you may have to work with polynomials of higher degree. Not just in math, I guess, almost any science field, because polynomials pop up in a lot of places. But polynomials of degree 5 or higher don't have a formula you can use to solve this. Yeah, degree 2 they do. Degree 3 they do. I don't remember what the formula looks like. Degree 4, I saw the formula once, and it's really not a nice formula. It's there, but it's really not that nice. But degree 5 or higher, there is no formula. So not in this class, but if you go into other classes, factoring is really going to be important, although factoring is important in this class. So anyway, so we have the quadratic formula. For the range, remember the domain is all real numbers. That's always true. For the range, that will really depend on A and the vertex. Yeah, you can graph it, of course, just to see what the range is. However, remember, if A is, let me draw this out. If A is positive, right? If A is positive, let me just write it out. Oh boy, well, looks like an A, I think. Then the range, then the graph's going to look like this, as you can see. So then the graph will look like this. If, again, A is positive, okay? And so what does that tell you? Well, that tells you that the vertex is going to be down here. Again, that's where the graph makes a U-turn, so to say. The range is going to go from the y-coordinate of the vertex. What it is will depend on B and A, and the function f, and the function we're dealing with. And it's going to go up to infinity, as you can see. And if A happens to be negative, remember, A can't be 0, so the only choices are positive, negative, or 0. Then the graph's going to do this. It's going to be down. You may not see the arrows in the graph, but this is understood. And here, the range will look something like this. Minus infinity, comma. Then you'll have a number, which is the y-coordinate of the vertex. Okay, but that's what the range will look like. So that's good. You know, it's got to be one or the other. Okay, so that's what we have here. But even without graphing it, we can figure out the range. I mean, you could actually get the range from the equation, although I guess that's what this is showing you. But generally, it's not easy to get the range without a graph. All right, so we have this. Let's dive right in and do an example. So from here, here's an example. We have a is 1, okay? Right? We have x squared minus 6 times x plus 5. A is 1. We have b is minus 6, okay? We also have c is 5. So using that vertex formula here, we can figure out what the vertex is. I mean, either way, you're going to have to calculate this. Negative b over 2 times a. So we get negative b over 2 times a. This is equal to negative 6 over 2 times 1. What am I doing? Like so. I'm pointing at the wrong thing, sorry. I meant to point at this. And so we get negative 6 over 2, which is 6 over 2. You know, double negative, staff and sun rules. You get 3. And so from here, we can figure out the y coordinate. I mean, right away, we know what the axis of symmetry is as well. Let's get the y coordinate. I mean, I know it's down here, but let's calculate it. F of this, as you can see, we get f of 3, right? That's what negative b over 2a is. That's equal to f of 3. That's equal to 3 squared minus 6 times 3 plus 5, as you can see. And of course, this is equal to 9 minus 18 plus 5, which is this. So we get negative 4. So this is what we get here. We have the axis of symmetry. And again, the y-intercept, I didn't show the calculation here, but you can still see it, I hope. I mean, if you replace x by 0, these terms are gone, and you're just left with 5. And right away also, we can get the range. I mean, yeah, we can graph it, but let's get the range anyway for fun. Since a is positive, right? That tells us that the graph will look something like this. As you can see, so we know the graph has to do something like this. Thus, the range is going to do this. It's going to be from minus 4, right? The vertex is down here. And remember, for the range, you're looking at the y coordinates. So you're going to go from minus 4 all the way to infinity. Right? You just look at the y coordinates and the graph is going up. The y coordinates keep on increasing. This is the range. Okay, now I did this for the other class also. So let me say it for you guys. Since the vertex, right, it's 3, negative 4, so it's going to be somewhere in this quadrant. Okay? We know the graph has to go up. You know, a is positive. What is that telling us? Well, that's telling us the graph is going to have to cross the x-axis. Even before we get to the, the quadratic formula, we can see that the graph has to intersect the x-axis. I mean, where? That's what we have to figure out. But at least we know ahead of time that it's going to have to intersect. You know, it might be negative where it crosses the x-axis, but we know it has to cross the x-axis. So if we're working with the quadratic formula, and somehow we get only one x-intercept or none, then we know we did something wrong. I'm just trying to get you guys to see what the calculations are telling us, so, to really understand what's happening. So from here, as you can see, You have A is 1, B is -6, and C is 5. So from there, we can replace in the quadratic formula. I mean, factoring, you could probably do with this one. This one's not too hard to factor. Let's just work with the quadratic formula. You have -6 plus or minus the square root of -6 squared minus 4 times 1 times 5. And we're dividing by 2. Now from here, right, we have to figure out what this stuff is. You know, we have -6. Yeah, that becomes 6. We have 36 minus 20. -6 squared is 36. Here we get 20, as you can see. And so we get 6 plus or minus the square root of 16 over 2. And what's nice about this is 16 is a perfect square. So the square root of 16 turns out to be a number. It's 4, well, it's an integer. It's 4. 16 is a perfect square. So we get 6 plus or minus 4 over 2. And there are 2 solutions. We have addition, right? You have plus or minus here. So with plus, you get 1 solution. And with minus, you get another one, as you can see. So we have 6 plus 4 over 10, and over 2 is 5. 6 minus 4 is 2, 2 over 2 is 1. So we have 2 solutions, 1 and 5. And this is what the graph looks like. I know it's kind of, you might be thinking, why is he doing this? We could just graph it in GeoGebra. I still think it's good practice that you can get the vertex, the axis of symmetry and stuff. You know, I'm not going to ask you to graph it by hand on a take-home test. You know, in-class test I would, but you should still be able to calculate this material. The axis of symmetry is going to look like this. Now, I didn't draw it here, but I'm drawing it now. And so we get this. You know, here's the vertex. Here is our y-intercept, as you can see. We have our x-intercepts, 2 of them, like so. And, you know, maybe you could see it from the graph also. I hope you can. But the range is from -4 up to infinity. Now, you're looking at all possible y values. You can get them by drawing horizontal lines, but, you know, we saw what the range is already. Yeah.
So when finding the x-intercepts, should we always just stick with the quadratic formula instead of factoring?
For these questions, I would, yeah.
Okay.
Good, awesome question. I mean, you still want to be able to factor, but generally in these kinds of questions, when you're calculating like the vertex and all that, I would just use the, what do you call it, the quadratic formula. Awesome question. Any other questions? What was I going to say? I mean, you don't want to rely on a graphing calculator, or something like Desmos 100%. You still want to be able to graph it by hand. I just figured with a take-home exam, you know, I guess that'd be kind of silly for me to ask. But this stuff is still important. And again, factoring is still useful. I'm not saying the quadratic formula is not useful, but it's still good to be able to factor. Okay. Before we get to this, let me just do this. All right.